A man in China last week hit a car riding his motorcycle, yet he was still untouched. As Newton once said, an object in motion certainly will stay in motion. Honestly, how did he not see that coming? Well, in the absence of a net force, a body at rest remains at rest, and a body in motion remains in motion indefinitely along the same straight line. Okay, moving on. Speaking of crashing, in the middle of nowhere last Tuesday, two trains collided at 90 miles per hour. Boy, that was some crash. It was all staged for a state fair that was going on in the area. California, actually. This obviously explains Newton's second law perfectly. The law states that objects that collide at equal forces will have a net force and acceleration of zero. So, if the two objects are equal in mass and speed initially, they will continue to be equal when they crash. Now for Newton's third law. MLB Reds closer Aroldis Chapman was carried off on a stretcher after being struck in the face by a line drive off the bat of Royals catcher Salvador Perez, creating a terrifying moment and abruptly ending Wednesday night's game in the sixth inning. As you can see, the pitcher's face exerted an equal and opposite force on the baseball.
Earthquake shaking and damage is the result of two main basic types of waves. The first kind of body wave is the P wave, or primary wave. This is the fastest kind of seismic wave and consequently the first to arrive at a seismic station. The P wave pushes and pulls the rock it moves through, just like the sound waves push and pull the air. The second wave is an S wave, or a secondary wave. It moves slower than the P wave and shakes the ground back and forth perpendicular to the direction the wave is moving. Maybe you've noticed, or maybe you haven't, but sometimes when you vibrate a string or a cord or a chain or cable, it's possible to get it to vibrate in a manner such that you are generating a wave. But the wave doesn't propagate, it just sits there vibrating up and down in place. Such a wave is called a standing wave.
Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. This is referred to as a constant acceleration since the velocity is changing by a constant amount each second. An object with a constant acceleration should not be confused with an object with a constant velocity. Displacement is a vector quantity that refers to how far out of place an object is. A physics teacher walks 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. Even though the physics teacher has walked a total distance of 12 meters, her displacement is 0 meters. During the course of her motion, she has covered 12 meters of ground. Yet when she has finished walking, she is not out of place, i.e. there is no displacement of her motion. Displacement, being a vector quantity, must give attention to direction. The 4 meters east cancels the 4 meters west, and the 2 meters south cancels the 2 meters north. Speed is a scalar quantity that refers to how fast an object is moving. Speed can be thought of as a rate at which the object covers distance. A fast-moving object has a high speed and covers a relatively large distance in a short amount of time. Contrast this to a slow-moving object that has a low speed. It covers a relatively small amount of distance in the same amount of time. An object with no movement at all has a zero speed.